Hey, Bio30s, and welcome to our final discussion today in the reproduction and prenatal development unit. Today I'm going to be discussing parturition and lactation and a little bit about uh, teratogens. We'll be discussing that as well. So first of all, what is parturition? Very fancy word for the birthing process, otherwise known as labor. Um, Today I'll be discussing the three stages of labor, which starts off with the dilation phase, then the expulsion phase, and then the third and final phase, which is the placental stage. Um, we'll first look at dilation. Dilation refers to basically the cervix, which is that entryway we talked about between the vagina and the uterus, that basically dilates from the size of a Cheerio to the size of a bagel in a few hours, depending on how long the dilation phase takes. And this is basically spurred on by hormones. In particular, it is spurred on by a hormone that you're very familiar with from the endocrine unit, oxytocin, which, as I mentioned earlier in the course, is one of the few and only hormones that has a positive feedback loop. And we're going to see both of the positive feedback loops today that oxytocin is involved in. One, which is the contraction of the uterine muscles, which basically continues with dilation, as well as the positive feedback loop that it exerts on the mammary glands when it's involved in the production of breast milk. And I'll get to that later today. So the cervix, again, the dilation phase can take as little as roughly 2 hours, or it can take as long as up to 20 hours, depending on the individual. But again, it is driven through the release of oxytocin. And what I've got up here on the board is sort of the feedback loop that oxytocin is involved in when it comes to labor. As well as oxytocin, there are other hormones that are not hormones, but hormone-like substances that are called prostaglandins that are produced by the placenta, which reinforce the positive feedback loop of the oxytocin. You might remember that males produce prostaglandins in their seminal vesicles, and it's part of semen, which basically creates contractions during intercourse to basically draw the sperm further into the female's reproductive system. In this case, the prostaglandins are there to reinforce the positive feedback loop that's being exerted by the oxytocin. So let's kind of take a quick look at the whole feedback loop, just in case anybody maybe forgot about it or just wants a recap. So essentially, the hypothalamus is calling the shots as per usual. It's going to have neural control over the post pit, which is releasing the oxytocin. Remember, the post pit doesn't produce its own hormones. It only releases hormones that are produced by the hypothalamus, and it's under neural control by the hypothalamus, as opposed to the ant pit, the anterior pituitary, which is under hormonal control of the hypothalamus. So the post pit is going to release oxytocin, and what's it going to target? Well, in this case, it's going to target the uterine walls, specifically the myometrium, which is the middle layer between the parametrium on the outside and the endometrium on the inside. It's the smooth muscular layer in between them, and it's going to start causing contractions. Well, those uterine contractions are going to do two things. One, it's going to obviously take the head of the baby. The baby's head's going to get pushed up because remember, the baby has flipped around during the third trimester, its head down, so that we don't get what's called a breech birth, which I'll discuss a little bit here today. And the head's going to push up against the cervix. The cervix has all these nerve endings, and those nerve endings are going to send basically positive feedback messages to the hypothalamus to basically tell the post pit to release more oxytocin. So during the dilation phase, what you probably already know if you've heard about this, maybe you know someone in your family that's given birth, basically the contractions get closer together. And the reason why that happens is because of this positive feedback loop that's exerted when the baby's head pushes up against the cervix. That basically sends messages to the hypothalamus to basically release more oxytocin, which causes more uterine contractions. At the same time, the uterine contractions are also going to basically have a bit of a positive effect on the placenta, which is going to release these prostaglandins. Now, the prostaglandins don't have any impact directly on the hypothalamus, but they will basically go back right to the uterine walls, embed themselves in the uterine walls, which will cause more contractions to occur. So you've got contractional messages being sent from the hypothalamus in the form of oxytocin through the release of its release to the postpit, and you've got prostaglandins, which are being released by the placenta, both of which are targeting the uterine walls to contract. And as well, the baby's head pushing up against the cervix also causes the uterine walls to contract as well. So there's sort of a triple positive feedback loop going on here in relation to these uterine contractions that are occurring during labor. At some point during this process of the dilation phase, the amniotic sac is going to break. There's a plug that's basically plugging the uterus. The cervix has a plug in it to prevent any of the amniotic fluid from leaking out. At this point, that plug will basically break. The amniotic sac or the amniotic fluid will break. You'll get what's called basically called the breaking of water. This is where most, that's usually what you'll see in movies or whatever. My water broke. That's what they're referring to with water breaking during this process. I've given you, there's a slide here that basically references the feedback loops I just discussed earlier. So if you want to take a look at that in the slides, it's right there for you. You're more than welcome to take a peek at that. Okay, so now the cervix is dilated from the size of a Cheerio to the size of a bagel. Yeah, big difference. Anyways, it's dilated now. We're ready to go. It's big enough now. The opening is big enough to basically start phase 2, the expulsion phase. This is basically where the baby is born. The head is obviously wanting to come out first. We want the head to come out first. It's the toughest part to basically get out because it's so big. It's usually the most dangerous part of the birth is to get the head out. Once the head's out, it's actually fairly straightforward, but it's much more straightforward once the head of the baby is basically crowned out of the vaginal opening or through the birth canal at that point. This stage where the uterine contractions are now pushing the baby out of the birth canal into the outside world, this is going to take about 30 minutes to 2 hours, depending on how fast or how slow the process occurs. And the contractions at this point are roughly 1 to 2 minutes apart during this phase. So again, that positive feedback loop is kicking in to basically try to expel the baby in a fairly timely manner. At this stage, you can use what are called epidurals. Epidural anesthesia is sometimes some women do natural birth, but there are some women who basically would like to have an epidural, which is a needle, which is basically put in their spine. It basically puts, it numbs their pain receptors that basically, so they're not feeling the pain of the birth. And it basically helps stop the mother, if the mother's feeling a lot of pain during the birth, they can have an epidural. So that can be done during this process as well. The last stage, once the baby is born, is the placental stage. The baby's born now. Now the placenta has to basically get out of the uterus as well. So that's going to occur roughly 10 to 15 minutes after the baby is born. The placenta and the umbilical cord will be expelled from the uterus. This is now referred to as afterbirth once it exits the uterus and out of the birth canal. The umbilical cord at this point will be clamped, cut and tied. The cord will eventually shrivel, and the place where the cord is attached is obviously the navel or the belly button. That's where your umbilical cord would have been attached to your body, and that's why you've got a belly button or a navel, whatever you want to call it. There are some interesting things that are done with afterbirth. In case you hadn't heard of this, or maybe you didn't want to hear about this, there's something known as a placentophagy. Placento meaning placenta, and phagy. Anytime you hear the word phage in biology, it means to devour. Remember, we talked about macrophages, very large devourers that are white blood cells. Yeah, so there are actually women who save the afterbirth and actually consume it. And it can be done in many ways. It can be done, it can be dried, it can be made into capsules, it can be ripped off into a chunk, placed in their gums. I'm not sure if anyone barbecues it, I don't know, but usually it's in capsule form. But there have been supposedly, there are health benefits to this. And right now, the debate is still raging about this, whether there is any scientific benefit, any health benefit to doing this. But there are many people who are convinced that eating the placenta or the afterbirth after they give birth will give them an energy boost. It will encourage milk production. Will even prevent what's called postpartum depression. You may have heard of that. That's depression that's experienced by 1 in 10 women after they give birth to a baby. If you're interested, or at all, not that I'm going to test you on this, but if you're interested in placental phagy, give this video a watch. Kind of an interesting little take on what it's all about and what the studies have been out there to show whether or not it's beneficial or whether it's not a good idea or a good idea. Again, give it a watch and maybe decide for yourself if that's something that, if you're a mother in the future, you want to do. Okay. Now let's discuss something other than eating your placenta. There are some females, some ladies out there that like to give birth in water. These are known as water births. There are specialized chambers that have been devised. Again, there is debate about this, whether or not this is a safer or better way to give birth to a baby. But proponents believe that the water birth does result in a more relaxed, less painful experience that promotes health for both the mother and the baby that is being born. Critics, though, argue that it can actually lead to potential infection because the tub, if it's not sterilized properly in the water, the female and the baby might come into contact with potential pathogens that are in the water. And there's also the possibility, could the infant drown? Well, obviously, if you've got a practitioner with you or a midwife with you, that shouldn't be an issue. But the bigger issue might be, I think, the infection that might perhaps come out of being born sort of in a water environment as opposed to in the air. Not that there aren't pathogens in the air as well, right? But again, another way for perhaps expectant mothers out there to perhaps help with the process of the expulsion phase and the dilation phase, which are obviously not very comfortable, as you could probably well imagine based on what I've been discussing today. Sometimes births through the birth canal are not possible. This is when you get a cesarean or a C-section. They basically cut an opening through the abdomen. The baby is then basically born through the abdominal wall rather than the birth canal. This can be done for a number of reasons. If the baby hasn't turned properly during the third trimester and it's feet first, which would be called a breech birth, we don't want to have a baby giving a breech birth because that can obviously cause some major trouble. You always should be the head first during a normal delivery. If the mother has an STI, maybe gonorrhea or herpes, which can be transmitted to the baby during birth, they would also provide the mother with a C-section to prevent the transmission of the STI to the baby. If the mother has a very small pelvis compared to the baby's size, that could be another reason why a C-section is done. If the baby is exceptionally large, same idea. If the baby's too large for the mother to deliver, C-section could be done. And if the mother has high blood pressure, all that contracting and pushing could potentially lead to some health issues for the mother if she's got high blood pressure. So there are many reasons why a C-section might be done instead. All right, that's our discussion about birth. Again, recap it. Part 4 of our 4-part series of the reproductive system, courtesy of Crash Course. Give that sucker a watch and you can finally finish up the quadrilogy. It wouldn't be the trilogy. The quadrilogy, maybe, the tetrilogy of Crash Course videos that is basically taking us through the male reproductive, female reproductive, prenatal development, and now birth. So give that one a watch and you can kind of tile the loose ends together, as it were. A couple more topics today and we're done. Let's talk lactation. Now the baby's born. Got to feed that baby. Mammals, again, all mammals have this in common. They give their babies nourishment through breast milk. That's one of the defining characteristics of all mammals, whether they're placental mammals or whether they're monotremes, which are egg-laying mammals like a platypus, or whether they're a marsupial like a kangaroo that gives birth to a partially developed fetus, and then that fetus has to crawl into a pouch. Regardless of the type of mammal we're dealing with, they all provide babies with breast milk, and humans are no exception. Lactation is the process by which we form the milk, and then or the females would secrete the milk. Now, men wouldn't do that, obviously. Females are basically the ones doing that. There are 2 hormones at play here, and we've discussed both of these hormones in the endocrine system. I discussed one earlier today. You got prolactin, which is the one responsible for the production of milk, and then oxytocin, which is going to be released to then release the milk to actually lactate the milk out of the breast. So we'll discuss both of these right now. Both the feedback loops, by the way, are drawn up here on the board. And again, these are feedback loops that we've discussed before, but I will break them down for you one more time. So milk production which is basically under the control of prolactin. Prolactin is released by the ant pit, and the ant pit is under the control of the hypothalamus. So basically, we didn't discuss the releasing mechanism in the endocrine unit for prolactin. You don't need to officially know it for the course, but in case you're wondering what it is, it's actually a combination of dopamine, which we discussed was a neurotransmitter, as well as TRH, which is the one that normally stimulates the release of TSH, which stimulates the thyroid gland. So these two kind of play into they're the releasing act of the releasers from the hypothalamus that are going to target the ant pit. The ant pit will then release prolactin. The prolactin will then target the mammary glands. The mammary glands will then produce milk, which is then going to cause the baby to suckle. When the baby suckles, obviously it's consuming milk, so that would be the positive feedback loop for the mother to then basically reactivate the hypothalamus to then basically start the whole process over again. The mother will only produce so much milk, and until the baby suckles to actually drink the milk, there won't be any more milk made. You have to wait for that baby to suckle at the breast, at the nipple, to basically create more milk in the breast. So again, it's a positive feedback loop as long as the baby is suckling. There is a reason why mothers do not produce breast milk during pregnancy. That has to do with the fact that the progesterone and estrogen levels are so high from the placenta that there is no production of milk until near the end of pregnancy. And I didn't mention that earlier in the video, but the end of pregnancy will, just before the start of the birthing process of parturition, there's a significant drop in estrogen and progesterone levels. That's one of the triggers that starts the actual birthing process. But it also helps to begin the production of breast milk later in the pregnancy as the levels of progesterone and estrogen begin to drop near the end of pregnancy. That's when the female begins to produce more breast milk in anticipation of the upcoming birth and the soon-to-be baby that needs to be fed. So that's milk production. That's how that works. And again, a little thing here. Oh, this is actually the next one. Pardon me. This is for oxytocin, which I'll be discussing right away. Oxytocin, which I discussed earlier today, helps with uterine contractions during the dilation and expulsion phase of the birth, but it also, after the birth, targets the mammary glands to actually release milk. And the mechanism is similar. There's a positive feedback loop that's caused by the baby suckling at the breast or at the nipple. That's going to basically cause the positive feedback loop on the hypothalamus. Now, the hypothalamus is going to only control the post pit, which is releasing the oxytocin. So remember, prolactin is released by the ant pit. Oxytocin is released by the post pit. Ant pit's a real gland. Post pit's like a gallbladder of the endocrine system. It just releases hormones that are produced by the hypothalamus. So the hypothalamus neurally controls the post pit to release oxytocin. It targets the mammary glands. They release the milk. That releasing of the milk is going to cause the baby to suckle. The suckling then is going to then cause a positive feedback loop, which will continue the release of milk until the baby stops suckling, and then the milk will stop releasing at the breast until the next time the baby actually starts suckling at the breast during its next milk meal. So that's basically how the two feedback loops work for both for both the production of milk and the release of milk as part of lactation. Today I want to finish up by just discussing a few developmental abnormalities that can occur. There is roughly a 2 to 3% chance in the province of Alberta, that a child will have some form of a birth defect. These can be everywhere from anything from a cleft palate to very minor, potential skin tags. But they can be they can obviously be way more severe depending on what happens during the pregnancy. Quite often, defects are caused by teratogens. We said it 4 times. Teratogens. Teratogens kind of sounds like mutagen, which is a term we've used for something that mutates DNA. But a teratogen is something that causes a birth defect. And there are all sorts of teratogens out there. And some of these are actually mutagens as well. They also can affect DNA. And perhaps that's the reason why they cause the birth defects, because they can also help to mutate the DNA of the developing baby, or the fetus or the embryo during its pregnancy. Cigarette smoke is a huge one. Low birth weight, premature birth, miscarriages can all be caused by excessive smoking during pregnancy. Alcohol. Alcohol can cause what's called fetal alcohol spectrum disorder, FASD, otherwise known as what's called fetal alcohol syndrome, or AFS. All sorts of issues here. This affects roughly 3 in every 1,000 births in Alberta. So it's about 0.3% of all the births in Alberta. And you can certainly take a look at all the stats about fetal alcohol syndrome on the page. And this is something that, people that are born with this, it's a lifelong disorder. They're basically, they're going to have it for life. So this is something that's obviously very important, that, alcohol consumption during pregnancy is obviously a huge issue, especially when it's at a certain point in development of the embryo, especially during neurulation. If the alcohol consumption is heavy during neurulation, when the central nervous system is forming, there can be some real issues. So there are definitely some windows where, alcohol should definitely not be consumed if at all possible. There's other drugs that can cause trouble: morphine, cocaine. Women that are drug addicts, their babies generally are underdeveloped, a low birth weight, and they also have the risk of being drug addicts themselves when they're born, because these drugs can cross the placenta to the baby, and the baby can become a drug addict on their own, and the babies actually have to basically be, they have to dry out after they're born, and they can go through withdrawal symptoms, which would be severe for an adult, let alone for a newborn baby. There's certain drugs out there that have been used in the past that have been issues. Accutane is a severe acne. It's a drug for severe acne. It can lead to low birth weight. Hydrocephaly, which is basically accumulation of cerebral spinal fluid in the brain, or it can also cause what's called microcephaly, where the brain doesn't develop fully and there's like a smaller brain. So microcephaly, small head, is basically what that refers to. And it can also lead to cleft palates as well. And a cleft palate would be here. Cleft palates are they're a fairly standard birth defect. A lot of kids do get cleft palates, and the surgery right now is unbelievable. You could have a kid who had a cleft palate, and after several surgeries, you would never know you would never know that the child, when they're growing up, had a cleft palate to begin with. So, but again, if you take certain drugs like Accutane, that can increase the risk of having a cleft palate. But cleft palates can occur without the use of Accutane for sure. There is another drug that maybe you've heard of called thalidomide. It was released in the 1950s. It was used to reduce morning sickness in pregnant women. The problem was it caused severe limb defects in the babies of the mothers who took it. There are right now, in 2015, which is only a few years back, there were 92 remaining thalidomide survivors in the country. They each received $125,000 each and an annual tax-free pension by the Canadian federal government, because the drug was promoted by the Canadian government, even though there were studies out there that were showing that it was actually potentially causing birth defects. They didn't maybe take it off the shelf as soon as they should have. So there were quite a few children that were born in the 1950s with birth defects, limb defects, because of the exposure to thalidomide during their development. You may have heard of what are called thalidomide babies. This is what that term refers to. Viruses can also be can cause birth defects as well. Rubella, otherwise known as German measles, it can cause something called congenital rubella syndrome, or CRS. If it's contracted before week 13 of the pregnancy, it's going to be really severe. Symptoms will include, if it's early in the pregnancy, if the mother contracts German measles, death, potentially, miscarriages. Stillborn babies are common at this point. If the fetus survives the infection, there can be issues like severe heart defects, cataracts or blindness, deafness, microcephaly, small-sized brain, and there could also be a blueberry muffin rash that develops on the body. If the mother contracts rubella during the second trimester, the serious symptoms cut down by half the risk. And if it's in the third trimester, the fetus is generally not affected at all, because by that point, all the major body systems have basically been developed, and the virus doesn't really affect the development. So the earlier in the pregnancy the female gets exposed to German measles or contracts the German measles virus, if she's infected, that is an issue for the baby. Obviously more in the embryonic stage than it would be during the fetal developmental stage. And again, another reason why vaccinate. If you're an expectant mother and you're not vaccinated for German measles, you're going to survive, but your baby potentially is going to have a lifelong battle with birth defects or health issues, if you contract the German measles early in your pregnancy if you're not vaccinated for that disorder. And finally, spina bifida is the last one. This is caused by an issue in their diet of the mother, lack of folic acid. This can cause essentially a non-closure in the spinal cord, where the spinal cord will actually bulge out of the vertebra that are on the so normally the spinal cord would be contained inside the vertebra, but if you have spina bifida, you can have either a bubble that has a little opening toward the spinal cord with no spinal cord in it, or in some cases the bubble will actually have the spinal cord in it, which is a severe issue for those babies. There's no cure for the nerve damage that's caused by spina bifida. Standard treatment is surgery after the delivery to prevent further damage to the nervous system. But there's only so much doctors can do if the spinal cord is outside of the spine, out of the backbone. So this is an issue where a lack of a substance in the diet can cause a birth defect. And that's basically that's the end of the unit. We're done. You don't have a lot to finish up on if you've been keeping up with the booklet through the last 2 videos on embryonic development and fetal development. In theory, you should only have 2 questions left in your prenatal development booklet. Those are going to be questions 10 and 11. If you haven't done any of the questions in the booklet, well, now is the time to complete that prenatal development booklet and get that into me as soon as possible. That will be basically your next homework assignment going into our review as we get ready to move on to our unit exam coming up in the next few days. Thanks for tuning in. Join me next time when we start our next unit, unit number 6. Only 2 units left to go, people. We're going to be discussing classical genetics. We're going to be discussing a monk in Austria who grew peas and changed the world. So won't you join me next time when I discuss classical genetics? Till then, folks, thanks for tuning in, and we'll see you soon.